Okay, I realized that I wasn't very detailed in something, so I want to give you a better explanation. That being, if you're dealing with something where there is a change in temperature, then what you're working with is you're working with Q equals M Cp delta T. Okay? So for instance, if you have the specific heat of water, water is changing temperature, you use the Cp. You'll also notice that there is a Cp for ice, and there is also a Cp for water, and they are not the same because it takes a different amount of energy to get the molecules jiggling faster in ice than it does the amount of energy it requires to jiggle the molecules faster in water. Now, the difference is if you look at something like ice warming, the energy in this part of the transition is not going into delta T. The temperature is staying at 0 degrees C for the ice the entire time. What's actually going on there is merely you're putting in heat for each gram of material. Now I want you to think about that, because if there was a little bit of ice, it would only take a little bit of heat before it all melts. If it's a large amount of ice, it's going to take a lot more heat before it all melts. So in this case, the heat of fusion, for instance, fusion in this case not being a nuclear reaction but being solid to liquid, liquid to solid transition, alright, the heat of fusion is going to be an amount of heat per gram, alright, per mass. So you'll notice that in this case Q, if you're trying to find the amount of Q, is going to be equal to the heat of fusion times the amount of grams, because the units on that are going to be joules per gram or joules per kilogram or whatever. Alright, so if you know this heat of fusion, then you would use the amount you would be able to determine the heat based on the number of grams. Or if you're trying to find the heat of fusion, obviously it's going to be the heat per gram as you did in the lab. Alright, so basically if we were going to follow a reaction from here someplace, for instance, to here someplace, then what we would need is in this section we would need the Cp of the solid. Here we would need the heat of fusion, and here we would need the Cp of the liquid. Alright, I hope that makes more sense. If you have questions, reply to this comment or put them in the chat. Not in the chat, but put them in the messages. Alright, or come to class with them. Hopefully this is helpful.